I think another important thing when you're doing sample size calculation that rarely gets taken into account is in a lot of studies it's quite possible that there's going to be missing data. For example, an animal might not survive to the end of a study and might have dropped out. So it's important to take that into account, or you might have values where the experiment's gone wrong, you've not been able to take a correct value of the measurement. That's quite simple to build into the sample size calculation, so you basically just increase it a bit. So if you'd calculated that 20 animals were needed per group and you thought, well, I'll allow for a 10% dropout rate, I think I'm going to have some missing data, then you would increase your sample size by 10%, say, well, actually I'm going to use 22 per group. I've rarely seen this done in biological or animal studies, but in clinical trials it's kind of done all the time. It's almost seen as something you need to do, you know, because patients might drop out of the trial before the end of it. You need to build that into the sample size calculation so you don't find, because a certain number have dropped out, but you've got reduced power at the end of the study.